The next thing we need to look at is the math. Math is a key part of astronomy. It's how we make and test predictions about the universe. However, this isn't a math class, so the approach we'll be taking here is that math is a tool that we need to learn how to use. The goal is not the math itself, it's how we use it to get a better understanding of astronomy.
There are three big topics we're going to look at here. First, we'll talk about the units of measurement we're using in this course. Then we'll discuss how we handle really big numbers with exponents. Finally, since we do a lot of word problems in this class, we'll go over how to tackle those.
Let's start with a basic question. How far away is the moon? Do you know how far away it is? Take a moment and think about it. All right, have you got an answer? Here are some of the possible answers. You could say it's 250,000 miles, or maybe 385,000 kilometers. How about 0.025 astronomical units, or 1.3 light seconds, or 1 moon unit? Okay, I made up that last one.
The point is that the numbers don't tell you enough. You can't just say 385,000 and have an answer. Every time you give a number, you've got to say what units you're talking about as well. Otherwise, the answer doesn't mean anything. So the key here is that units count.
There are many different kinds of units. There are units for measuring speed, for weight, for money, and so on. But in this class, almost all of the units we use are made up of combinations of just three types: units of mass, units of distance, and units of time. So whenever we're working with units, you want to make sure you know how they relate to these three.
For example, what about speed? Think about a typical speed unit. Miles per hour. Miles are distance units. Hours are time units. So miles per hour is just a distance divided by a time. Similarly, acceleration is distance divided by time squared. We'll work with this one more in a couple of chapters.
Lastly, make sure you know what type of unit you've got. Have a look at the sign at the bottom of the page. They haven't included the units on it, so you have to ask, are those numbers distances or times? This is in Britain, where sometimes they do list walking times to places. In fact, I think it is a distance in kilometers, but it's not obvious here. So make sure you're always clear about what type of units you've got. In science, and in everyday life outside of the US, the main units we use are from the metric system. The metric system is based on three simple units: grams, meters, and seconds. Notice that these are mass, distance, and time units, respectively. A meter is just a little bit more than a yard. A gram is 1/28 of an ounce, really small. And we all know what a second is.
The picture shows some of the original standards for some of the metric units. That long metal bar is a meter. The weight in the black case is a kilogram. That's 1,000 grams. And the jar is a liter, but that's a volume unit, and we won't be using it in this class. I just mentioned a kilogram. That's an example of one of the neat tricks you can do with metric units. No matter what base unit you've got, you can always make it larger or smaller by using prefixes. For example, the prefix kilo means 1,000. So a kilogram is 1,000 grams, just over 2 pounds. A kilometer is 1,000 meters, a little more than half a mile.
Another prefix is centi. It means 1/100th. So a centimeter is 1/100th of a meter. We use the centi prefix with our money. A cent is 1/100th of a dollar. Another prefix we'll see is nano. It means 1/1,000,000,000th. When we talk about light, we'll be working with wavelengths in nanometers. However, the metric units we'll see most often in this class are the kilogram, the second, the meter, and the kilometer. In addition to the basic metric units, There are several units that are not part of the standard metric system, but which we use a lot in astronomy anyways. The first one is the year, the time it takes the Earth to go around the Sun. This is 31.6 million seconds. If you really want to impress your friends, you can say that a year is just over pi times 10 to the 7th seconds. They'll all be amazed at what a nerd you've turned into. Next is a solar mass. In other words, the mass of the entire Sun. This is a 2 followed by 30 zeros kilograms.
This number points out a problem we're going to have to deal with next. What to do about ridiculously big numbers? We're going to see a lot of those, and you definitely don't want to have to write them out longhand like this all of the time.
We've done a time unit and a mass unit. The last three are distance units. A solar radius is the radius of the Sun. It's about 700,000 kilometers, or 700 million meters. We'll use this to describe the sizes of stars. An astronomical unit is the average distance between the Earth and the Sun. It's about 150 million kilometers, or 150 billion meters.
Lastly, we've got the light year. As you remember, this is a distance unit. It's the distance a beam of light travels in 1 year. It's about 10 trillion kilometers, or 63,240 astronomical units. You don't have to memorize all of these conversions. They will be available on exams if you need them. But you should get familiar with what these units mean and how to use them. We'll be seeing a lot of them this term.